if we look at slide 19, what's different about these two things? The ax squared plus bx plus c, that's our quadratic kind of formula. But what's different about these four down here? What's different about those four than this pattern? What's missing?
B.
Yeah, the b is missing. That b term, it actually makes it easier. So if all you have is the a term and the c term, you don't have any x's in there, then you can just take the square root of both sides. So let's see what that looks like. Hopefully this looks familiar to you. So we're still going to have two sets of parentheses, right? What's the square root of b squared? What's the square root of b squared? What times itself will give you b squared?
4.
B?
Wait.
You answered the 16. What's the square root of 16?
4.
4. So if I have the difference of two squares, b squared is a perfect square, I can do b, and 16 is a perfect square, I can do 4 and 4. And then I have to put a plus in the front and a minus in the back. That's all it is.
Oh, okay.
So what am I going to do for number 3? Take the square root of 9x squared. What's the square root of 9?
3.
3. What's the square root of x squared? What was the square root of b squared? So if b times b is b squared, then the square root of b is b. So the square root of x squared is x. Hello. Square root of 4? What's the square root of 4?
6 square root of 4?
Mm-hmm.
2.
Mm-hmm.
I almost said 16.
So a common thing to do is squaring instead of square rooting. And then I need 1 plus and 1 minus.
Does it matter which side it goes on, the plus or minus?
It does not. Nope. Because you're ultimately multiplying these two terms, and multiplication is commutative. It doesn't matter which one. So you've got b plus 4 and b minus 4 and 3x plus 2 and 3x minus 2. Doesn't matter which term has the plus and which term has the minus. So what would you do for number 5? And so what would that be, Lily? 4v and 4v. And then what about the second part of that term? Square root of 1 is?
Plus
Mm-hmm. Plus what?
b? No, sorry. Great question. I could do the plus.
What's this? Okay, so we got a plus and we've got a minus. What's the square root of 1?
4. 2.
What's the square root of 1?
Oh, minus 1.
Yeah. So when you have the difference of squares, this is just a special case. Take the square root of the first term, square root of the second term, plus and minus. Easy peasy. What about number 2?
Parentheses 5n. Well, I'm getting it. 5n plus 2. Oh, I'm too good at this. I'm literally too good at this. 5n plus 5. No, minus 5. I know. 2. Oh, did you go down?
From the 25. So you take the square root of the first term, 5n, you put it in the front, and then you take the square root of the second term. Square root of 4 is 2, 2 and 2. What about number 4?
Parentheses 4x plus 4.
Good thing it's not X, you know.
plus.
Oh, is it? You know, I cleared the wrong one. Are you serious?
And then 4x minus 3.
Beautiful.
Oh,
All we're doing is doing square roots, basically. And it's just a pattern that makes it a shortcut. You can still do these with that X method. So with the X method from yesterday, we would get -4 and 0. So that would be a -2 and a +2. Because there's no B term, that would be 0. But it's just easier, I think, to just do square roots. 2v -1 and +1.
And then -1.
Mm-hmm. This cuts out all of that re-putting everything together. Okay. This only works with difference of squares. So if I zoom back out, bless you, you'll see that every single one of these is perfect squares. And every single one of them only has 2 terms. And every single one has a minus sign in the middle. They're difference of squares. Okay? All the answers are here. If you click on the gray block box on slide 22, you can go to arrange and order and send to the back. And you have all of those answers that we just did. Shortcut for difference of squares. And I think this is what I just showed you. If you're doing the IXLs for extra credit, the one that practices this is AA6. So if you're doing those IXLs, it's AA6. Again, those are not necessary. If you want to do them, please feel free. If you don't want to do them, it's not going to hurt your grade. So lesson 4, factoring a trinomial completely. This is where we're going to put it all together, what we learned yesterday and what we learned today. Step number 1 is take out that greatest common factor, and then step 2 is factor. You can factor using that X puzzle, or you can factor using the difference of squares. So we're going to do these 6 questions, and then we'll be done for the day. So step number 1 is greatest common factor. What's our greatest common factor? Yeah, absolutely. If I take a 2 out and I put it outside the parentheses, I'm dividing everything by 2, and what ends up inside the parentheses? If I divide by 2, and I divide by 2, and I divide by 2. What do I put inside the parentheses? X squared. And what's half of 144? It's half of 144. Half of 140 is 70, and then half of 4 is 2. Okay. So now we've got this. And we need to do an X puzzle to break this apart. So if I do one of those X puzzles, 1 times minus 72, negative 72 goes on the top. That's what we did yesterday. You might want a piece of paper for these. And then the minus 1 goes on the bottom. What factors of 72 are only 1 apart on the number line? Well, if we don't know, we can do 72. We can do 1 and 72, 2 and 36. 72 is divisible by 3. 24. Why negative 9 and 8 instead of negative 8 and 9? So you want to end up with a negative 1. So the bigger of the 2 numbers has to have the same sign, right? So this number on the bottom, your bigger term has to have the same sign. So then when we put it all back together, what do I write first? This is our first term. X squared stays at the beginning. This is our last term. The minus 72 stays at the end. And then this is our middle stuff, but we got to make sure we put an X in there. So we're going to do minus 9X and 8X.
So 2, wait, is 2 on the outside?
2 is on the outside.
So X squared minus 9B.
9X.
9X.
It is a 9. 9X. And then 8X minus 72. Are we finished, or is there a greatest common factor I can take out of this?
I think we're finished.
Can I take the X out? So the 2, and then I can take the X out. And then I'm left with X minus 9. I feel like I'm going to run out of room here. Can I take a factor out of this? Is there a greatest common factor out of 8X minus 72? Is 8 a factor of 72? It is. So I can take the 8 out, and then X minus 8 or X minus 9. Like we did yesterday, these greatest common factors need to go into a set of parentheses together. So the 2 stays on the outside. That's the hardest part. That 2 stays on the outside. And then we have X plus 8 and X minus 9. And that is ultimately our final answer. That is fully factored. 2 times X plus 8 times X minus 9. Next year, your Algebra 2 teachers are going to have you take pictures of all of this work and upload your pictures.
Yeah, I just think that's good. I'm sorry.
So you are going to have to actually do the work. Unless you pay for the upgrade.
Nobody pays for the upgrade. Come on.
I don't know. Just saying. I'm going to erase this just because it's going to get super cluttered if I don't. So make sure you capture that in some way. We're going to do problem number 3. So what was our step number 1? Take out that greatest common factor. What's our greatest common factor? 4. So if I divide everything by 4, I end up with p squared minus 7p plus 10. Okay, so if you're at home, please write this on a piece of paper. If you're here, do the same. Now I've got to factor this. So using the X factor puzzle is, I think, the easiest way to do that. The minus 7 is in the middle. That's the B factor that goes to the bottom. And then 1 times 10 is 10. What factors of 10 will add up to negative 7? What factors of 10 will add up to negative 7? 5 and 2. And if I want a negative 7, what's the sign of my 5 and 2? Negative 5 and negative 2. So a negative times a negative is a positive. If I have a positive up here, both of these have to have the same sign. So then I can rewrite everything. I've got the 4, that's my greatest common factor. And then p squared minus 5p minus 2p plus 10. What? Right here. So these 2 side things in my X puzzle become these 2 things right here. So the first term comes down, the last term comes down, and we break apart that negative 7 into negative 5 and negative 2. There'll come a point where you've done this so many times that you don't need this X puzzle anymore. You'll just be able to say to yourself what multiplies to 10 and adds to negative 7 and be able to figure out what those 2 numbers are. Not quite yet. What can I pull out? Do I have a greatest common factor in p squared minus 5p? It is p. So then I've got p and p minus 5. And what can I pull out of this one? and I want to pull out a -2 because I want to end up with p minus 5. So that's the other hard part, is remembering to take out that negative sign. And then we got to reorder everything. So our greatest common factors go together.
Wait, is it -2 or is it?
It is p minus 2 and then p minus 5. And that's your final answer. Mm-hmm. What about number 5? What can I take out of that?
Oh.
What's the greatest common factor in number 5? 3.
Oh, 3, actually, wait, that's 3 on the
Yeah.
3 times 9.
How about 54? How many times does 3 run to 54?
27. What's 54 divided by 3?
18.
I knew that right off the top of my head.
Totally. Siri didn't help at all.
That's good.
What's 3 times 4?
So in our X puzzle, 18 and 9, what factors of 18 give you 9? What factors of 18 add up to 9? 6 and 3.
It's 7. Oh, it's 6 and 3. I'm just not, I'm just really good with that.
I switched my variables to X's. I don't know why I did that. Let me make them N's. So what can I distribute out? What's the greatest common factor in n squared and 6n? Make sure you keep that n separate. I like to try to put it in parentheses, but sometimes I forget. And then n plus 6. This is my greatest common factor from the second time. This is my greatest common factor from the first time. So this has to stay separate. And then what can I remove from the 3n plus 18? I only have one term with n, so I can't take the n out. The n's got to stay, which means I take out what? 3. That's the greatest common factor in the second term. And then 18 divided by 3 is? The n plus 6 stays together, n plus 6. The greatest common factors stay together, n plus 3. And this leading coefficient that we took out at the very beginning has to stay all by itself.
So that's the answer.
So this is our final answer. 3 times n plus 3 times n plus 6. This is 3 parentheses n plus 3 parentheses parentheses n plus 6. Close the parentheses. So that's an n. We good with those first 3? So I think the answer should be on page 26. So this one, what's missing in number 2? What's missing in number 2? That middle term, right? We don't have any r's to the first power. So what did we just learn we could do if we've got a perfect square minus a perfect square? There's a shortcut. We don't need to do that whole X puzzle thing. We can take out the greatest common factor first. So is there a greatest common factor? I think it might be. What's 324 divided by 4?
What is 324 divided by 4?
And then what can we do?
Anyone?
Well, she already knew that, so she didn't really need us.
What do we do with r squared minus 81? What do we just do in the first slide of today? When you have difference of squares, what can you do? What do I put in the first? What do I put in the second with a plus and a minus in the middle? R plus, what's the square root of 81?
I mean, 9, sorry.
So if r plus 9 is the first term, what's the second term? R minus 9. Difference of squares, you can just take the square root of both of them with a plus and a minus. It is definitely worthwhile memorizing this shortcut so you don't have to do all of that work we did with the first 3. If you recognize difference of squares, and they happen more often than you think they're going to. What about number 4? Is there a greatest common factor? Always ask yourself, is there a greatest common factor?
Would it be 4? I mean 2.
Is there a 2 in front of the k?
Yeah.
There's a power of 2, but there's not a coefficient of 2. So I like the idea because 2 would work for the middle term and 2 would work for the last term, but 2 is not going to work for the first one. So yeah, I think there's no greatest common factor. So there's none. I should actually just write none. So then we go to our x factor. What do I put in the top of the x puzzle? A times C goes in the top and B goes in the bottom. So what do I put in the top of my x puzzle? Positive or negative? Positive. You want to keep it. So negative 16 goes in the top. And what do I put in the bottom? Negative 2. So my question is, what multiplies to negative 16 and adds up to negative 2? What multiplies to negative 16 and adds up to negative 2? Anything?
Oh, shoot. So
what are my factors of 16?
I think it's going to be...
We could do 1 and 16. We could do 2 and 8. Or we could do 4 and 4.
No, it's going to be 4 and 4. It's going to be 4 and 8. No, it's 4.
So 4 and negative 2 aren't going to give me 16. They're going to give me 8. So does this work? Not factorable.
I'm too good at this.
Sometimes there will be some that are not factorable that you'll have to use a different method for. We'll learn the different method, I think, in lesson 7 or 8. I think it's actually lesson 8, so that'll be Friday. We won't do very many because they're kind of a pain in the neck. What do I do for number 6? This is our last problem of the day. Be so happy next year when I don't have to sit like this. We're supposed to stay behind our desks, not like be out in the room. So I suppose in theory I could stand right here, but then I'm not. Yeah. Yes, this is supposed to keep on. Do that?
It doesn't go with this. How is Kellum ranked second and we're ranked 11th in softball? We beat them. Doesn't make any sense.
That was so random.
No, but it doesn't make any sense.
I don't know.
No, it's just.
For softball or baseball or soccer? What are we talking about?
Softball, we went like 11 and 1.
I don't know. Anybody on the softball team?
No, but like it's stupid. No, it's not random. It's factual.
Is it based on what all the other games?
Yeah.
That's why. All right, last one, guys. Let's push through. What do I do first? Step number 1. Step number 1. What do we think?
Sorry. distracted really easily.
I got that. What's step number 1?
Subtract the greatest common factor.
Greatest common factor. What is the greatest common factor? So if I take out the greatest common factor, I've got x squared minus 2x minus, what's 75 divided by 5? 15, I think.
I said 15.
Can somebody just double check that? Is it really 15? Okay.
What is 75 divided by 5?
What goes in the top of my x puzzle?
Yeah, 15.
-15.
Negative 15. And what goes in the bottom of my x puzzle? Negative 2. What multiplies to negative 15 and adds up to negative 2?
5 times 3. 5 times negative 2.
Negative 5 has to match the negative 2, and a negative times a positive is a negative. So then I've got 5 and x squared minus 5x and 3x minus 15. And what can I take out of this? And I'm left with x minus 5. And what can I take out of this one?
3. I mean 5.
I think 3 was your best instinct. Then we've got our what's left over in the parentheses match. So we just put down the x minus 5. Make sure you bring down this 5. And then your greatest common factors from this step, whatever step that was, you put those together. X plus 3. So this will be your final answer. Okay? That is the final answer. There is a video on page 25 that you can definitely reference. There's also all of the rules again on page 25. Page 27.
I thought that was it.
There is. That's it. I just want to make sure. And then all your answers are here. So if you missed something that I did, all your answers are right here. Okay. If you want some extra practice, you can go to this link on Desmos. I will not have access to it, so that is for your own self-help. Tomorrow we'll talk about intercepts and zeros, and I think play some, well, maybe that's not till Friday. Yeah. That's it for today, guys. If you're on Zoom, you're free to go. Have a great day. And if you are here, we're here until 8:45.